periodic whatever shenanigans reaction by looking at this. So you first need to know about soluble and actually, do I want to put this here actually because I'm not going to explain the nodal planes until like way later. Yeah, it's fine. Who cares? All right, so that's done. All right, so yeah, why not? So you need to know about compounds that are soluble and insoluble. The thing about any rules is that in chemistry is that it's flexible. There's always some exceptions, so you have to kind of test everything out to see if in the real world this is how it would turn out. So you kind of have to look up in the real world. Hey, does this happen actually? If it does happen, then it's turned out to be true. So it's a science. It's a hard science because you have to figure things out, and you can't just assume because of a periodic table that this will quantify this. We can estimate and guess and have a well-educated guess on what will happen based on what happens in the above periodic table. For example, we can assume over here that if this is n, it will be a minus three. If the because it's three over here, minus three, minus three, minus three, but there might be further down the periodic table where minus three is not possible. No, sorry. Is it minus or plus three? Sorry, plus. No, it's minus. Minus. Minus three means you can add three. Maybe in like over here for some reason that it can't do plus three because of like the bi, which is I don't even know what that element is. This, yeah, the business is an interesting molecule, but anyway, so later on it might not happen. That's the idea of chemistry. So this is just a rule that is common. You can, and then that allows you to do complete ionic reactions that shows you this horrendous equation, which is why no one really used complete ionic reaction. I don't think. Well, that's what I was. I believe, but thinking about it, they might actually use it just as a. Ooh, actually, now thinking about it, I do need to show what the spectre ion is here. So a spectre ion is basically the ones that are completely useless and cancels out. Um, so, for example, 2NO, which is used to make calcium. I used to know this is a nitrate or nitrite. I don't remember. Oh well, is and Ca in this equation because it's not being used. Spectral ion is not being used. Therefore, it is a useless item that it's completely junk, it's trash, it's garbage. Uh, in terms of getting a solid. Now, what I meant to do was get these two items here, get a new thing, and then just draw out what the hell is going on with these two reactions and how we can visualize them. So the first thing we're going to do is visualize a complete one, aka this is a complete um, ionic. Oh, spell complete wrong. Complete. I need to be careful. Ionic reaction or equation. Sorry, is a equation because that's what it is. And then what does that visually tells you? It's basically when we have two liquids, I don't know what liquid we have, and these are assuming perfect ratio because usually there's leftover molecules and that's called excess ions and other shit. But for now, we're assuming we have some kind of perfect liquid, perfect reaction, perfect amount, and for some reason, odd reason, we can actually incorporate both of them to make a perfect base. But when we pour it into a big beaker like this, into it, we just pour it in, we get something like this. We have we have some liquid from both of those, and we have a solid material on the near the bottom or something. Probably gonna be a bottom because there's more solids there. Um, it's not gonna be obviously like this one big mass. It's probably gonna be like a smoke, like a smoky thing, like ribbons s- um, of solids that you have it like this, and it eventually goes in the bottom. It's probably gonna be like that. But for ionic reaction, you need to include the other molecules. Now, what? How about um, net? How about net um, ionic equations? So with net ionic equations, what you're assuming is that we have the same two documents, we have the same two liquids, the AQ. AQ is actually uh, different from a liquid for some reason, which, yeah, I still don't understand the difference between those two. Um, Still need to research a little bit more about that. I don't get it, and I don't need it right now, so whatever. If you have different AQs, let me write AQs over here. You do the same exact thing where we plug it into here. Yeah, you do something like this. You plug it in. You get the the eventual thing like this, but you only care about that solid. Basically, you only care about the solids. That pretty much is the visualization of an ionic and net ionic reaction. Is it important to know that? I have no idea. We'll see if it's important to know the visualization later if you're taking chemistry. Um, but that's what I pretty much know. Um, Yeah, there's a few other topics I need to talk about, like electrolytes, which is going to be fun as a trans. Electrolytes is basically, some liquid that usually a liquid. It could be something else, but usually a way for I forget actually. I believe the formal definition is ion leaving and entering again and again, but it could also be dissolving. I don't really know actually thinking about it. Thanks to that. So actually, I need to research that too.